Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we'll talk about the some of the visualizations methods that are available in Scikit-learn. Here is a list of methods that we'll look at, uh, starting with ROC curve display, calibration, partial dependence display. Some of these you've probably already seen, and it would be a recap on those. So basically, there is a display class in scikit-learn which has two methods, from underscore estimator and from underscore predictions, which can be used to visualize the data. The very first one is ROC curve display, and as we can see in this particular plot, we have false positive rate on the x-axis and true positive rate on the y-axis. So the higher this curve is, the blue line that we see, the closer it is to the top left corner, the better it is. And if the line runs diagonal, then we can say that the classifier is not doing a good job at classifying the data points. Here the AUC, that is the area under the curve, is 0.86. And this is code snippet from the docs where we can see how it is implemented. So after fitting to the classifier, we can use this method ROC curve display dot from underscore estimator, and we pass the classifier and the test data, and that's how we'll get that particular plot. Now to get an overlay of plots such as this one, as you can see, the blue line is a perfect fit, and that's probably overfitting. To get overlay plot, in addition to the code that we saw earlier, we can add these lines where we have ROC display from estimator, and this is using another classifier, so random forest classifier. Again, you can use the X test and the same axis, and you can create the plot. So here I have not shown the how RFC was created, but that would be just the random forest classifier. Next, we have the calibration display dot from underscore prediction. So calibration display or calibration curves are used to see if the classifier is well calibrated. That is to say, if you're looking at just classification as to ones and zeros, this may not be that important. But if you are looking at the actual probabilities, then this would be important. The plot has the mean predicted value probability on the x-axis and the fraction of positives on the y-axis. And the way to interpret this is, the dotted line is the diagonal line running through the plot, and the closer the calibrated line is to this dotted line, the better calibrated the classifier is. So in this case, the blue line is far away, and that tells that the classifier is not well calibrated, whereas the orange line shows that the value classifier is well calibrated. And here is the implementation of that. Essentially, we hit a classifier, then get the probabilities from the classifier using the test set, and then use calibration dot display from underscore predictions y test and y probabilities, and that will create the plot that we saw earlier. Next, this is the partial dependence display dot from estimators. This is the plot we saw earlier as well. Here we have here what we are trying to do is see if a particular feature in the data set has an effect on the target target, and in doing so we can find out if that particular feature is important. So here we can see that the feature 0 is shown on the x-axis. We have the partial dependence the y-axis, and here the curve is uh, moving up in this case as the values for the feature 0 are increasing, and that but the way this curve is moving up is in a staggered fashion. So It's not a complete linear increase. Looks like it's like a stepwise increase. And again, on the right hand side, we have another plot which shows the uh, effect of feature 0 and feature 1 together on the target variable. So here we can see these in the contour plots that are shown. So if the feature 0 is greater than 2.8 and the feature 1 is greater than zero point 0.4, then this seems to generate a higher values the uh, for the target, whereas values of feature 0 features below feature 0 below 0.2 are and 0.2 and the values for feature 1 below 0.3 does not seem to have much effect as they are the same color here. And this is the implementation of that. We can use the partial dependence display dot from underscore estimator, specify the classifier along with the inputs. And this is the feature, and this tuple is for the contour plot that we saw. Next is the confusion matrix display, which you've probably already seen. And here we have the predicted labels and true labels, and this is your true negatives, positives, and so on. So this diagonal elements tell how many of the classes were correctly classified, and off diagonal elements show the mistakes made by the classifier. Here is the implementation for that. We fit the classifier, get the predictions out, and then use the confusion matrix to create the plot. So CM is equal to confusion underscore matrix, y underscore test is applied with the predicted values, and then use that in the confusion matrix display. If you can also simply plot CM, but if you plot it with confusion matrix display, get this nice heat map with the scale and the labelings along with the numbers within each of those boxes. Next, we have the detection error trade-off curve, DET curve display, as we can see. So here the x-axis has false positive rate and the y-axis has false negative rate. This kind of another way of looking at the data uh, at the output, similar to the ROC AUC curve we saw earlier. And the implementation is again similar. We get the values for false positive rate, false negative rate using the DET underscore curve, y test, y pred, and then use that as an input to DET curve display to get the plot that we saw earlier. Next, we have the precision recall display. So here's we have the recall on the x-axis, precision on the y-axis. Pretty straightforward. And on here we have the precision recall display uh, method that can be used to create the plot. Next, we have the ROC curve display, same that we saw earlier, this is the repetition, but the way to call this is here we are using matrix.roc curve display, and this using again false positive rate, true positive rate, and ROC underscore AUC. So that's the matrix. Looks like there's a typo here, and that can be used to generate the display plot. So that was it for this video. I hope in this very brief video you have some knowledge about, have new knowledge about how to use the libraries within Scikit-learn to create these plots very easily. And if you have any comments or suggestions, please let me know in the comment section below. I hope to see you all in the next video. Till then, please like, share, and subscribe. Thank you.